Alrighty, check to make sure I've got, yep, there we go. I've got my wireless mic up and working. So even though the top of this worksheet says rotation bonus practice, I assure you this is dilation practice and bonus practice. Like I've been doing with the other bonus practices, I'm only going to do part of them because, again, the goal is for you to get as much practice with these as you can. So I'm going to do the first four, and hopefully that will yeah, hopefully that'll clear things up for you. If you have any questions about how to do any dilations or expansions, the main video is also up. You can check that out. This is just bonus practice. So the idea is that you understand the principles of how to do this. You just need a few extra points and a few extra shapes in order to refine that skill even farther. So let's go ahead and get started. Dilation from origin. All of them are going to be dilation from origin. Oh, except for this one, we're not doing that. All of them are going to be dilation from origin, scale factor 2. So that means whenever we're referring to scale factor, that means that it's going to be K equals 2. And if you remember the rule about dilation and expansion, um, for X and Y, you're going to do an expansion K. All that's going to be is Kx times Ky. And that's all it's going to be. That's all the dilation that it's going to be. So what that means is scale factor 2, I'm going to take every point, I'm going to take every coordinate in A, B, and C, and I'm just going to multiply them by 2. That is really all the dilation is. So for A prime, 2 times negative 3 is negative 6, 2 times 2 is 4, and that's A. Let's move on to B while we just got the mojo going. 2 times 0 is 0, 4 times 2 is 8, and there we go. There's that one. So move on to C. 2 times 2 is 4, and 2 times 1 is 2. So there we go. That's A, B, and C. Because of the 0.1.1, it looks like I'm just going to be doing the first three. So hopefully that doesn't bother you. Maybe I'll throw up a supplement to augment this, but for the most part, we're just going to be doing dilations from the origins and things like that. All right, so I've got rectangle PQRS. So I've got 4 points. I've got 4 points. There we go. Now it's on screen. I've got 4 points, but it's not going to change anything about what I do because I can see I've got scale factor 0.5. So that means that K equals 0.5. So whatever the points are, I'm going to multiply the X coordinate and the Y coordinate by 0.5. And that'll give me my new prime notation coordinates. So let's take a look. I've got P prime. Negative 6 times 0.5 is negative 3. Negative 2 times 0.5 is negative 1. I mean, that's pretty much it. I mean, it's more, I mean, really at this point, it's more busy work than it is challenging work, but, you know, we'll work through it. We'll work through it here. So I've got Q prime. Negative 2 times 0.5 is negative 1. And negative 1 again because it's the same value multiplied by the same constant. All righty. R prime. Negative 2 times 0.5 is negative 1. 2 times 0.5 is 1. There we go. Finally, S prime. Negative 6 times 0.5 is negative 3. And then 2 times 0.5 is 1. All right. I mean, we're doing pretty well so far. We're moving on up pretty quickly. So let's go with dilation scale factor negative 1. You know what? I don't think we're going to see a problem like this on the assessment. I think they're always going to be positive and greater than 0. But what the heck? Let's just see what this looks like. You know what? I'm even going to graph it. Let's see. I have to pick one of these to graph. I'm going to graph this one. I just want to see what it looks like. I'm just curious to see what it looks like because we've got the process down. I mean, this is the dilation process. And problems like this one and this one are pretty much going to be the only ones you see on the assessment. So well, let's have a little bit of a fun here. Let's have a little bit of fun. Let's see what happens when the scale factor is negative 1. And we'll see what that turns into. All right, so it's quadrilateral 2, of course, because why not? You do 4 points. So W prime is equal to, because we're just taking scale factor of negative 1, that means that we're just flipping the signs. So negative becomes positive, positive becomes negative, otherwise it's the same thing. All right, so that's 2, negative 3. X prime, so I've got 1, 3, that makes it negative 1, negative 3. y prime is going to be -2, -6, and then z prime is going to be 1, -6. I think that this isn't really going to be a scale factor as much as it is going to be a 180-degree rotation because of how the x's and the y's change. But yeah, I think it's just going to be a 180-degree rotation. But we never know. Let's just take a look, see what we've got here. All right, so I'll do the pre-image first. So I'm going to draw this here. All right. So I'm going to do the pre-image first. So that's going to give me -2, 3. So 1, 2, 1, 2, 3. Then 1, 3. So 1, 1, 2, 3. Then I've got 2, 6. So that's 1, 2, 1, 2, 3, 4, 5, 6. And then -1, 6. So -1, 1, 2, 3, 4, 5, 6. All right. So we've got a quadrilateral. Oh, it's a decent looking parallelogram or rhombus or whatever we want to do. So let's see what everything looks like here. So I've got 2. Let's see what the k factor of -1 looks like. So I've got 2, 1, 2, -3, 1, 2, 3. Not looking great. -1, -3. So I got -1, 1, 2, 3. Mm-hmm. Then I've got -2, -6. 1, 2, 1, 2, 3, 4, 5, 6. Yeah, I think I called it. And then z of 1 to -6, 1, 1, 2, 3, 4, 5, 6. Yep, yep, yep. All I did was rotate it about 180 degrees. Yeah, well, all right. I mean, I guess there's worse things that you can do, worse things we can go for. I'm going to look up the I'm going to look up really quickly. Editing, Richard, please pay attention. I'm going to look up really quickly how to do problems like this as far as dilations are concerned. If I can do it, then I'm going to do a quick video of how I do this problem and how I solve it. If it can't be done, just if you wouldn't mind doing a cutaway and ending the video on a high note, maybe a joke or a magic trick. That'd be pretty cool if you could do like a magic trick that kind of liven things up. Anyway, either way, folks, this is the dilation practice. You're going to be dealing with k is going to be greater than 0, and it's going to be greater than 0, and you're always going to be from the origin. But just in case you want to see what it looks like to do it from the other point, I'm going to look it up, and if I come back on and show you how, then it's possible and it's easy and we can do it. If not, I imagine editing Richard is going to be doing a magic trick for you. So there we go.